Hi, welcome to Social Research Insights. My name is Kamakshi Musunuru. I am Principal Consultant at Social Research Insights. Social Research Insights is not a business organization, it is a freelance training outfit. We provide training related to data science, analytics, and IoT. We have a lot of content online. All the content is absolutely free. However, we have a request. Please consider us calling for some staff development and faculty development programs. This is one of my video demonstrations which related to a series of presentations related to healthcare analytics. In my previous videos I've explained few models related to quality improvement or quality management in healthcare organizations or healthcare systems or hospitals. All of them are same, but in short we refer always hospitals as healthcare systems. Every hospital is a system. I explained a particular concept called capability index by using R programming language, or in short R language. There is one particular concept which is left remaining, that which is related to the same concept or theory. I explained about the two important scenarios related to capability index. That is, one, when the underlying distribution is perceived as normally distributed, and second scenario when the underlying distribution is not perceived as normally distributed. In this video I'm going to show you how to calculate a particular capability index which is around a given target. So this target is very, very important. Sometimes the hospitals also would like to know the capability of the hospital or healthcare system around a particular target. So we'll be using the same data as in my previous examples. In my previous examples I dealt with a numerical vector called cases, number of cases. We are trying to define the capability of the hospital with respect to the number of cases that was successfully handled in a given day or in a given month, something like that. I simulated some data sets in R by using a couple of simulation functions, because it's not possible every time to have the real-time data. At times I need to use numerical simulations to create the data sets and all. I'm going to follow the same discipline even now for this demonstration. I'm going to simulate a data set for the same context, that is the number of cases handled by the hospital. We are trying to define the capability of the hospital through number of cases handled by the, and I also defined what is the capability in my previous videos. And this video I'm going to show you how to handle the capability index around a particular target, or I don't know whether I can call it as a threshold or not, because we already have enough amount of theory in statistics around this particular world called threshold. But I can say usually in quality management people refer this to capability index given some target. And there is another interesting name for the same concept called Taguchi capability index. So when we calculate the capability index around a particular target, which is referred to Taguchi's capability index, we are trying to estimate the capability of the hospital around a given specification, which is known as target. So the formula for that is, actually the notation for the capability index around a particular target is CPM, which is going to be like this: the capability index CP, which is an estimated value, divided by square root of, which means we are trying to standardize the denominator, 1 plus mu hat, which is the central value of the given distribution, minus T. This is actually the highlight of the present distribution, present demonstration. The T stands for the target, and there is some communities in quality management also refer T which is in reference to the one of the well-known, world-renowned quality management expert known as Taguchi. So T stands for the target. At the same time, T also stands for this name Taguchi. And now we have to divide this with the standard deviation. It is also an expected value. That is why we put the hat. And this particular quantity should be raised to 2, to the degree 2. So, and this square root is applied for the entire denominator. So this is how we try to define the Taguchi's capability index, or Taguchi capability index, which is in strict theoretical statement for the same is the capability index around or given some target. So what we need to do here is that we need to find the CP, and to find the CP you need to go to my previous videos. We have a wonderful expression, that is USL minus LSL divided by 6 sigma. So we are estimating the capability index at 6 sigma limits or threshold or specifications, whatever it is. And first we need to find the capability index, and later we carry this particular value and substitute in the upper expression while substituting other remaining but imperative quantities in the denominator. So what we need is the target and a central value of the distribution, which is the mean of the distribution, standard deviation of the distribution, and then SCP, which is capability index. So you please go through my previous videos where I'm going to use the same script file in R. So let me go to the capability index around mean, which is I demonstrated a particular scenario where the underlying distribution follows the normality property, where we assume that the distribution which we are trying to study is roughly normal or sufficiently normal, something like that. So I already have that the capability index with me. I think it is better to follow here. I think I also have the same, yeah, CPK. It is around mean. So let me go for this capability. I think I have capability index USL minus LSL divided by 6 times the standard deviation. Here I have the mean, and here I have the standard deviation, here I have the variance. We have R is a wonderful programming language, especially for statistical analysis. There are wonderful functions available for all and variegated needs of the statistical procedures. So let me test if I have this particular quantity capability. Yeah, I have capability index. I have. So let me take the same. I need to simulate once again. I think it is not possible for me to, because already done. So cases. Yeah, let us follow this. Nothing wrong, because I am just employing some simulated data sets. So these are all assumption, fictitious and fake. Why? Because I have a valid reason. It is not possible for me to take the real-time data sets, and it is possible for you. If you are watching this video, probably you are in need of this concept. You'll be having some data sets in your hand. Please try to use those data sets in order to follow this procedure. So now let us make the I think we already have the mean. Yeah, we have the mean. This is a 94. We have the central value for this particular distribution, which represents the number of cases that were successfully handled by the hospital. The mean value is 94, and the capability index is, I think it cannot be. Capability index cannot be. We have to go to the standard error, right? USL, I think I have taken the variance here, so that is not possible. So let me correct. I will take the cases, standard error, standard deviation. I think I don't have that particular. Yeah, now I'll be having standard deviation divided by square root of, because we need to substitute the length of cases. This is the correct expression for the, let me put let me check my parenthesis. Yeah, I think okay. Okay. Now the same thing I need to substitute here also, LSL. Should go for the yeah, let me substitute the entire quantity here. Now it's okay. Enter. Now let's go to the console and check USL LSL. Now let us substitute and compute once again. USL minus 6 standard deviations. Yes. Yeah. Let's go to the console and check the capability index. Yeah, now it is 0.11. This is correct value. So there was a mistake in my previous calculations, not in the other videos. Like, this is only for this session. Now it makes some sense for our situation. The capability index is positive, but however it is less than 1, which means the hospital is not able to demonstrate required level of capability as far as the number of cases that was successfully handled by in a given month. So this is how we conclude. Now let us go for capability index around a particular target value. So now I make some assumption that what is the capability, because you say we have so many, there are so many disadvantages in this particular measure, capability index, because we don't know exactly what is happening behind the operations. Like let's say for example we have 26 cases handled in the day 1, 44 in day 2 and 219 in day 3. So it seems to be that the hospital is ready even for the 219 cases, but something is happening, here say there are only 2. So we can make a reasonable assumption that the number of patients are not arriving to the hospital for care. So this can be one of the assumptions, because when the hospital is able to handle just one case in a given day, and at the same time it is able to handle 154 cases, so we can suspect actually the capability. No, we cannot conclude that the hospital really lack the capability. There may be a problem in the demand, so the healthcare consumers may not be turning up in those particular days. Something is happening behind the event or experiment or this particular phenomenon. So given such assumptions, or when we start suspecting the not the hospital but the market, or from the demand side, not from the supply side, then we can make a reasonable value by assuming or supplying a target. It is actually user supplied specification, not the USL or LSL. In this case it is mean. Okay, so please be cautious of the formula. This is the so we are estimating the capability index given the standardized value of the difference between the actual mean to the targeted value so we are standardizing difference, and then we are again further standardizing with the help of square root, and then find the fact and factoring the capability ratio with the help of that denominator value. That is what we are trying to do here. So let us follow the same expression. So what I do, I just go down, and here Taguchi capability index, this is what is called. So now the expression you should be Taguchi capability index. I just put it as very simple, so that let me avoid typing more number of letters when I go back to the. So let me start the parenthesis and let me put the CP capability. We have that value in capability index. Capability index divided by square root of is a function available from the R programming language, which computes the square root for us, and then I again have to 1 plus, then start the parenthesis because we have a quantity to compute. Mean cases dot mean minus, let's take little if I put the mean, then it will become 0, then the square root of 0 becomes let's take the mean. What happens if I take the mean? So because we will be left with only 1, square root of 1, and CP dash. So we are just estimating the capability index around the distribution mean. mean divided by this particular quantity divided by standard deviation, cases dot standard deviation, and that should be raised to the square, that is 2. Then finally we have this, I think the square goes to this. Yeah, I have to come up with one more parenthesis here. Now it is okay. This square goes to only the denominator, that to the right side of the denominator. Now I can I have to come up with one more parenthesis. Now press enter. TCI. Let's go to the console. TCI. Okay, that's exactly the value that we have. So if we consider the mean value as a target, then we end up with the same value. So we are estimating the capability index for roughly for the same, because when it simply means that when we use the upper specification limit and lower specification limit, and we divide it with the help of 6 standard deviation. So this is none other than a mean value, right? So what we are taking the average of the both specifications and divide it by the 3 sigma minus 3 plus 3 for 60. So it will turn out to be the same thing. So now what we do, we'll just create a value that is some particular standard deviations apart from the mean. Let us take, we suspect that our mean value is we'll take the mean value of the distribution and we make plus some standard deviation. So I'm indirectly asking a question, what is the capability of the hospital exactly 1.5 standard deviations away from the mean value right side. Why? Because I am putting plus here. I think you are able to understand what I am trying to talk. This is the mean of the distribution, and now this is 1, 2, 3. Here we have here minus 3. So 3 plus 3 is 6 standard deviations. When we estimate the capability index for the 6 standard deviations, that is actually the estimation around the mean. That is why when we are using the target as mean, so the mean and mean cancel together in the denominator, mean hat and the target cancel together for given standard deviation. So what remains underneath the numerator is actually the 1. So that is why we are just getting the same value. Now let us multiply, it is not the plus actually, let us multiply the mu in, with 1.5, which means we are increasing the value mu to 1.5 standard deviations, and then we'll try to propose this as a target value here, the value here, and then try to find out. So let me put the target t as is equal to, or I put, because t is target is equal to cases, I think I should go down, end of the target. Let me put the cases mean multiply 1.5. So let's go to the console and see what is there in the target. TARG target. Why did not it come? Yeah, targ 141. Yeah, this seems to be a bit it makes a sense to substitute this value. Now we can just simply put it substitute 141 instead of cases mean here, and let's see what's going to happen. So I think you are able to follow what I'm trying to do. Instead of proposing mean as a target, I am proposing a particular value which is away from 1.5 standard deviations away from the mean of the distribution. So I'll take a rough value 142. Then let's see what's going to happen. TCI this time. TCI. Yeah, it's reducing. So we still may not be able to claim that. So earlier it is better the hospital, lesser the target, better the capability of the hospital. So we cannot increase the target, we can only reduce the target. So the lesser the target is better. So if the target is 0, then the value becomes close to the capability index. Now let's see what's going to happen if I put some value below the mean value, which means I try to take a target and divide it with target is equal to cases mean divided by 1.5. Let me take this time the target in a different fashion. I needn't put 142 here because I created an object target. I can place target. Let's first see what is there in the target. Yeah, 62. It is below mean. Now this time let's substitute the target and see what's going to happen. Go to the console and see the capability index around target. Yeah, it's increasing. So lesser the mean, the capability is increasing. So it's clear that the hospital cannot claim that it is ready for the demand of the market. So there is nothing wrong in the market demand, but the hospital itself is suffering from the maybe we don't know the reason. Actually, the data, we only have the data that which speaks over the number of cases that were being handled successfully by the hospital. So if we take that particular issue into the consideration, so the hospital cannot claim that the hospital is really ready to handle the demand irrespective of the capability of the hospital. So there is something wrong in the hospital. This way we can come to conclusion, or we can try to add some sense to the data. I hope you understand how to compute the Taguchi capability index, which is also known as the capability index around a particular specification or target. If you like my video, please press like. Kindly don't press on like, and stay tuned. Subscribe to my channel. Stay tuned for the new content. Thank you very much.